Hi guys, hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In our channel, we deal with different aspects of mathematics, physics, chemistry, and biology. So today we're going to look at a concept in radio chemistry or radio physics, and this is going to be a discussion on natural and artificial radioactive substances. This is going to complement on the earlier discussion we have had on an introduction to radioactivity. And this discussion for today basically is going to create a distinction between elements which are going to undergo natural radioactivity and others which are going to be initiated through bombardment, perhaps in order to initiate that process of radioactivity. Now, in our discussion, I'm going to remind us of a particular definition of the concept of radioactivity. And we had stated in our first discussion that radioactivity basically refers to a spontaneous. I'm just going to choose terms so that we can be able to just create a distinction or perhaps a summary from this specific definition. So radioactivity refers to the spontaneous disintegration of unstable atomic nuclei in order to form stable ones. And this process is accompanied by the release of energy and particles. And this energy we're going to see is going to appear in form of an ionizing energy. And of course, we're going to see that this is going to result in the formation of new nucleides, which we're going to refer to as daughter cells in some of our discussion. Now, I've mentioned about the concept of emission of ionizing radiation and perhaps the release of energy in form of electromagnetic radiation. So in this specific case, there's going to be a release of particles as well, which in some cases are referred to as nuclei. So in this case, we're going to create an emphasis on this and try to see which are some of the substances which are going to undergo this specific process. But I've mentioned the concept of spontaneous, and this perhaps means that there is no external influence that is going to cause this process. It's a natural one and it occurs spontaneously, and perhaps one cannot pinpoint which specific part of this is going to initiate the process. But later on, as we're going to discuss, I've put in our heading the concept of artificial. We're going to see how some of the substances which are going to undergo this process of radioactivity can be initiated artificially. So to start with, of course, this concept of naturally occurring radioactive substances came by through the various discoveries that were, of course, done through the historical timeline. But of essence for us is to understand from the basic concept of atomic structure, whereby we say that an atom is made up of subatomic particles which entail the neutrons, protons, and electrons. And we said that much of the mass of electron is concentrated around this center in the nucleus. And therefore, we say that since the mass is concentrated at this particular point, and the radioactivity is a mass transformation process, and therefore it's going to entail the concept of a nucleus. So therefore, we concluded that the radioactivity is a nucleus process, and this is going to form a basis for our discussion. So in actual sense, if we try to discuss about the concept of the nucleus being involved in radioactivity, we have said that atoms are different, atoms of specific elements are different and unique from one another. But we're going to see the case of perhaps isotopes and other which are going to display a variation in mass and perhaps mass numbers and atomic numbers. And we're going to have a different name for that. But in that case, if you try to assume that all the atoms of unique elements are different from one another, then there's going to be a variation of the mass numbers and atomic numbers, which basically are displayed in the periodic table. I'm going to put a link of the discussion, the vivid discussion we had on the periodic table and the trends across the periodic table of various elements. And we're going to see that this specific process of radioactivity falls under the category of, or rather is widely displayed in category of elements that we refer to as actinides. And we're going to see how this mass number and atomic number of these various elements are going to create a specific series or characteristics that we can, of course, pinpoint that this is where the radioactive process starts from insofar as the mass number and atomic numbers are concerned. So that is going to be a discussion basically that is going to entail on the characteristics of the nucleus, and that is going to be a follow-up topic perhaps on this. But going forward, in this particular case, I've mentioned about the concept of the nucleus. And if we try to consider the nucleus and its constituents, we say that it's made up of the neutrons and the protons. And therefore, this one creates what we call the nucleons. And whenever this specific part of the atom, which is a nucleus, is formed, there is involvement of what we call binding energy, which is the energy that is involved, of course, in a formation of this, or bringing together these constituents of the nucleus. So whenever we're going to dissociate or try to break down this nucleus and come up with its various constituents, then therefore we're going to have an involvement of this binding energy either being released or used in order to create this specific part of the nucleus. Now this one dictates the nature of the stability of elements across the periodic table, in a sense that the binding energy is directly proportional to the energy that is going to be required to split away this, or to split down these constituents of or to split down the nucleus into its various constituents. Therefore, that is going to give us a stability, a sense of stability for each particular nucleus of different elements insofar as the trend across the periodic table is concerned for all the natural and artificial elements. Now, in this particular sense, then therefore, we're going to see that there's going to be a case whereby the stability of this specific nucleus is compromised. Now, this is perhaps due to the fact that some of the short range and strong forces that are being experienced in this nucleus due to its formation have been compromised, and therefore this is going to lead to the concept of a nuclear instability. Now, this nuclear instability cannot be, of course, contained in the natural case. So therefore, this nucleus is going to tend to either attain some constituents or split and release some energy in order to attain stability. Now, this encompasses the process of natural radioactivity. And we're going to see that in nature there are some elements which are going to display what we call radioactive series. And this basically is different steps which an element is going to undergo in order to attain that stability. Now, naturally, we have what we call 3 radioactive series, and these ones are the uranium series, and then we have what we call the thorium series, and what we call the actinium series, or the actinium series. And these are the 3 series which are naturally occurring series, which of course are going to undergo radioactivity, and the end product is going to be lead, which is going to be formed, which is a stable, of course, isotope that is going to be formed from this particular case. Now, in this case, we are going to see that in between this series, there are going to be a range of isotopes which are going to be formed. And in this particular case, I refer to as elements which have got specific atomic and mass numbers which are going to be formed. But for them to be stable, they have to undergo several transformations in order to form this final product, which is known as lead. And as from our definition, we have said that there's there are various products which are going to be achieved from these specific decay processes. And one of them is the alpha particles, which are going to be released. And then we are going to have the beta emissions, and then we're going to have alpha, beta, and gamma, which are going to be, of course, experienced in this specific. So sometimes we're going to encounter the positron and perhaps other emissions which are going to be, of course, experienced, whereby we're going to see that some elements are going to undergo some aspects like electron capture in order to, of course, achieve these other forms of stability. But of essence for us is to try and figure out how this specific uranium, thorium, and actinium series, which are naturally occurring, are going to occur, and which are some of the elements that are found in between, which are going to lead to the final product of stability. Now, there's a unique one that we're going to mention, of course, in this particular case, which is naturally, it's not a naturally occurring series, and this is basically going to be what we refer to as the neptunium series. And the neptunium series is an artificial series that was, of course, pioneered by Curie and Joliet. So this is Frederick Joliet Curie and, of course, Irene Joliet Curie, who are the couples who pioneered this specific discovery of the neptunium series, which is, of course, is an artificial one, in contrast to what we have looked at, which is a naturally occurring one. So we're going to look at this individual series in a display form, which I think is going to be elaborate after our video. But of essence for us is to try and understand the concepts in between. And we are going to see for the last case that, which is an artificial one, which is an interest for us in this specific case, apart from the natural one. I'm going to just shortly illustrate how this specific process was achieved in a summary form, and then we can be able to see the relationship that exists between artificial and the natural occurring radioactive series. Now, in this particular case, I've mentioned the work of the Friedrich Joliet Curie and Irene Joliet Curie, who are the couples. Actually, Irene was the daughter of Maria Curie, who pioneered the concept of, who was one of the scientists who pioneered the concept of radioactivity. We're going to see that Maria, together with her husband, did an intensive study on polonium and radium, which basically led to, or rather created a foundation for the discovery of other radioactive processes. She basically scampered due to the exposure of radioactive rays, and of course we're going to see that those are one of the negative effects of this particular radioactivity. Now, Joliet and the husband, of course, Joliet Curie, Frederick Joliet Curie, and Irene, of course, discovered that when polonium and aluminum were bombarded with the alpha rays, and we're going to see that we can be able to represent these alpha rays using that specific notation. They discovered that the alpha rays, when the aluminum and boron were bombarded with the alpha rays, this continued to produce what we refer to as positrons. So we're going to also to look at the positron emissions as part of the radioactive processes. So this was achieved after the alpha source was removed. Now, in this particular case, we have done a number of illustrations that we can use to show what we call a radioactive decay. And in this case, perhaps I'm going to use the concept of this aluminium that was bombarded with the alpha rays and try to see which are some of the products that this couple achieved. So this is aluminium, which is being bombarded by the alpha rays. And then the product that was formed was phosphorus, which is 3015. And then there was what we call a positron that was, of course, the experiment resulted in the emission of a neutron, which is being illustrated on that other end. So in this case, when the alpha source was removed, it was found that the phosphorus that was produced as an isotope continued to emit this alpha rays, of course, with a specific kind of half-life. And we can be able to represent also this specific decay using this process. So this subsequent one resulted in the addition of a positron. And this, in a summary, is trying to imply how this process was done. Of course, for the first case, the couple bombarded aluminium with the alpha source, and then this resulted in the formation of an isotope of phosphorus, and then there was an accompaniment of what we refer to as the neutron. So in this case, when the phosphorus, the alpha source was removed from the system, the phosphorus continued to, of course, emit this particular positron, and therefore this gave an insight into the concept of artificial radioactivity, which laid a foundation for the later discovery of deuterium and deuterium, which of course were acting as good bombarding sources that will assist in discovery of other ways in which we can be able to achieve radioactive processes. So this, of course, is going to complement on the aspect of natural radioactivity that we have look into. And as we said, of course, the transformation of these elements is going to be accompanied by release of energy. So in us trying to quantify this energy, then therefore we're going to be able to calculate the nuclear binding energy and other characteristics of this specific nucleus of different elements that are undergoing the concept of radioactivity. So basically from this, the natural, artificial, and artificial radioactive substances are going to fall under these three categories that I've mentioned in summary form for the actinium, thorium, and the uranium series. And lastly, the neptunium series, which of course was an artificial kind of a series whose foundation was, of course, done by Irene and Frederick Joliet Curie, which I've given as an example on the board. Now we're going to use some concepts from our last video on the discussion of the periodic table and the various trends. And as I had mentioned in one of part of this video, I had said that the actinide series forms a range of radioactive elements. And this is going to be handy where one, of course, we're trying to compare the periodic table and trends and trying to visualize the mass and atomic numbers and how different transformations are going to occur across these four series for the three natural ones and the one artificial series and other related patterns. So our next video is going to entail the concept of patterns of nuclear stability, and we're going to see how different ratios of the protons and neutrons are going to play a role in trying to, of course, explain these stability trends of these radioactive elements. And this is going to assist us, of course, in trying to figure out how we can describe this actinium and thorium, uranium, and neptunium series respectively. So catch us in our next videos where we're going to look at other ways in which we can describe these concepts of radioactive substances, especially on the ratio between the neutrons and the protons, as I've said, which of course is going to give us a characteristic way in which we can be able to trace the trends across the periodic table. So that is it for now, guys. Bye. God bless you.